Not so long ago, we relied on a range of appliances to perform everyday tasks. A TV set for visual entertainment, perhaps connected to a VCR to watch movies. A telephone to contact friends. A film camera to record our favorite scenes. A video camera to record family movies. A computer to execute spreadsheet calculations and manage the family budget. Today, thanks to the digital revolution and the evolution of coding, all these functions and more can be performed by a single device, a smartphone. Coding is responsible for transforming everyday devices and a growing list of smart devices. Coding impacts our travel, manufacturing, entertainment, finance, just about every aspect of our daily lives. As coding permeates more and more of our everyday lives, the demand for programmers in a variety of fields is growing and offers some of the best career opportunities for today and the foreseeable future. So what is coding, and how did it all start? As early as 1725, the weaving industry attempted to automate looms using paper tape with holes punched in it. In 1804, Joseph Jacquard demonstrated a loom controlled by a chain of punched-out cards that could produce intricate patterns in woven silk. Each card held the instructions for raising and lowering the warp in each pass of the shuttle. Punched cards continued to be used in a series of applications, including Charles Babbage's calculating engine and Jules Carpentier's musical mellotrope. These early attempts were more a means to control equipment than to handle data. This changed when Herman Hollerith developed punched card data processing technology for the 1890 U.S. Census. Hollerith founded the Tabulating Machine Company, which later amalgamated with 3 other companies to form a new enterprise that would ultimately become International Business Machines Corporation, IBM. Punched cards operated on the principle of 2 states, or a binary system. A hole would either be present or it would not. Data could thus be represented by a string of ones or zeros. A given occurrence of a 0 or 1 is called a bit. A sequential string of 8 bits offers 256 different combinations, and such a string is referred to as a byte. In 1960, the American Standards Association, now the American National Standards Institute, or ANSI, began work on the American Standard Code for Information Interchange. The goal was to provide a commonly recognized standard to represent alphabetic, lowercase and capitalized characters, numbers, and various special characters. Each time a key is pressed on the computer keyboard, the binary string represents the selected character, symbol, or number, and is transmitted to the computer for processing. Dealing in purely zeros and ones would be a time-consuming way to get anything done. So just as the keyboard converts a character into a byte of zeros and ones, it became necessary to develop a form of shorthand to make it easier for humans to produce the binary digits for computers to operate on. The solution? Programming languages, which have been developed to compile source code into a binary form for computer processing. The first widely used high-level programming language, Fortran, was invented at IBM by John Backus in 1954. Fortran stands for Formula Translating. Fortran was a huge advance over its early predecessors. It was fast and it included conditional branching. Up until this time, most programming languages could only process a list of instructions in a given order. With conditional branching, the next step could depend on the result of the previous step. Program statements could now include such logic statements as, if results equals X, then go to, else go to. From 1955 to 1959, United States Rear Admiral Grace Hopper developed what would become Commons Business-Oriented Language, or COBOL. Other early languages included BASIC and Pascal, named after famed mathematician Blaise Pascal. Pascal proved to be a good teaching tool, but lost favor when C was developed between 1969 and 1973. C was fast and powerful and is still in use today. It's the foundation on which popular operating systems such as Windows, Unix, and Mac OS are built. Programming language innovation continues to this day. In 2014, Swift was developed as a general-purpose, compiled programming language for iOS and other Apple platforms. An alternative to Objective-C, Swift offers a simpler syntax. Syntax refers to the rules governing the sequence and placement of symbols and words to communicate with the computer. Swift's syntax now makes it easier for any programmer to understand this programming language. Today, some 700 programming languages are commonly used across a variety of applications. Each of these programming languages tends to fall into one of three building blocks. System programming languages are designed to build and maintain an operating system. They offer direct access to the system's components, such as the hard drive or CD-ROM DVD device. C, C++, and assembler are the most common examples of system programming languages. Architectural programming languages are designed to build frameworks around applications such as Microsoft's .NET. Frameworks contain common processes and tasks that can make it easier for programmers to develop apps. This makes writing software applications more efficient and less time-consuming. Java is an architectural programming language in common use. The third building block is application programming languages. These are used to build the applications used by businesses and consumers today. Languages commonly used are PHP, Ruby, Perl, and Python. Word processor and spreadsheet software, such as Microsoft's Word and Excel applications, are built using application programming languages. Other examples include your web browser, such as Google's Chrome, and social media websites, such as Facebook. A programmer's skill set is not necessarily limited to programming languages. Data manipulation might require knowledge of MySQL, a structured query language. Developers of websites will need to be proficient in HTML, the hypertext markup language, and cascading style sheets, CSS, a styling language. Learning code is easier than most people think. Coding boot camps are an excellent starting point for students looking to learn how to program. Many of these schools have hiring connections with big tech companies like Facebook and Hulu to help jumpstart a career after graduating their program. A global movement sponsored by Computer Science Education Week and Code.org has sponsored Hour of Code. Hour of Code is an easily accessible one-hour introduction to computer science and computer programming. Participants can build their own Star Wars galaxy, take part in the Minecraft universe, and learn to create fun drawings, all using code. This nonprofit organization echoes the sentiments of Steve Jobs as the founder of Apple.
I think everybody in this country should learn how to program a computer, should learn a computer language, because it teaches you how to think. Computer programming teaches you in a slightly different way how to think.
Computer giant Microsoft also encourages coding education with its popular game Minecraft, a fun gaming environment using strings of code. Chair of Microsoft Bill Gates also shared his thoughts on this kind of innovation. Learning to write programs stretches your mind and helps you think better, creates a way of thinking that I think is helpful in all domains. Many of the parts that make up the objects we use every day are manufactured on robotically operated production lines using components that may have been fashioned by computer numerically controlled lathes, CNC, or milling machines, all controlled by lines of code. Global security and aerospace company Lockheed Martin are the developers of the F-35 Joint Strike Fighter. This new stealth fighter began production in 2001, but is constantly being refined. In order to build the world's most advanced stealth fighter jet, over 8 million lines of code, or MLOCs, had to be developed, integrated, tested, and finessed. According to Lockheed Martin's coding standards for the F-35, C++ is a highly used language to ensure system stability. General Electric, a company operating in over 175 countries, is also a major code developer. Their diversified interests include aircraft engines, power generation, oil and gas production equipment, infrastructure, medical imaging, and financing. Because of this multifaceted industry influence, massive amounts of code are required to get their products working smoothly. For example, turbines must be calibrated to efficiently power cities, communicate with other safeguards, and increase output and reliability. Another way GE utilizes code is to control highway lighting, which must be programmed to save money by determining the optimum times to turn lights on and off. Perhaps one of the most popular examples of the importance of and innovation in coding can be seen in the social media world. Facebook is 100% code, yet connects with over 1.5 billion users. According to Facebook's Mark Zuckerberg, learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline. It started off because I wanted to do one simple thing. I wanted to make something that was fun for myself and my sisters. I wrote this little program and basically just added a little bit to it. And then when I needed to learn something new, I looked it up, either in a book or on the internet, and added a little bit to it. As of December 2015, Facebook employs over 12,000 people, many of whom directly support or create new code for the company. Zuckerberg continued by stating, "Our policy is to literally hire as many talented engineers as we can find. The whole limit in the system is just that there aren't enough people who are trained and have these skills today." As for preferred languages, Facebook runs their servers on Linux, Apache, MySQL, and PHP. A recent study showed that SQL is the most in-demand programming language. Java is second, JavaScript is third, C# is fourth, and the fifth highest in demand is Python. According to Code.org, there are currently 508,247 open computing jobs nationwide. Yet, only 42,969 computer science students graduated into the workforce, leaving a shortfall of 465,278 jobs simply waiting to be filled. Aside from programming positions in support of manufacturing and product development, a massive range of other opportunities is available. The level of sophistication present in today's electronic and online games is a world apart from what was available just a few years ago. Compare Pac-Man to the realistic multiplayer and virtual reality games available today, and you thank programmers for the giant steps taken in coding development. This entertainment and media market in the U.S. alone is scheduled to be in excess of $720 billion by 2020. Similar development in the Internet has led to opportunities related to communications, web development, and e-commerce. While traditional storefront operations are struggling, annual global e-commerce has surpassed $1.5 trillion in sales, all driven by code. As programs evolve, errors or omissions can be made that may expose vulnerabilities in the application that can lead to problems. Computer viruses can exploit these vulnerabilities, or worse, they can be exploited by hackers. Hackers generally fall into two categories: white hat, the goodies, and black hat, the baddies. White hat hackers are employed to expose vulnerabilities and fix them before they can be exploited by black hat hackers. Black hat hackers, or crackers, often steal information, such as credit card details they can then sell or directly use to drain funds from owners' accounts. Another ploy is to extort money by blackmail using ransomware. If the hacker can find an opening through which he or she can load their ransomware, the infected computer will lock up and cannot be unlocked until the hacker unlocks it, having been paid the specified ransom through some untraceable online currency, such as Bitcoin. Increases in the number of frequency of cyber attacks and cyber crimes are driving up demand for paid white hackers to combat and guard against such attacks. This continuing battle demands the best brains to match and defeat the ever-developing threats. New technologies, such as artificial intelligence or AI, are spawning exciting new possibilities. The idea behind AI is to get computers to develop their own code. AI is definitely a coming technology, as exemplified by IBM's Watson, and to a much lesser extent by Apple's Siri and Amazon's Alexa. It is one of the building blocks for the SpaceX program, aimed at manned transportation to Mars. AI may also lead to robotic maids and butlers becoming commonplace around the house, performing tasks such as cooking, cleaning, and yard work. Based on manipulating the state of electrons to process calculations infinitely faster, quantum computing is an exciting new theory that will cause an explosion of new technology if practical limits can be overcome. A career in coding can lead to high pay and unique challenges. Career choices include system programmer, architectural programmer, application programmer, software engineer, systems analyst, web developer, assembler language programmer, database analyst, or even as a hardware specialist, linking physical components to work together. The IT sector is predicted to experience a 26% increase in total jobs between 2016 and 2026, making this an excellent career choice. When it comes to vocations, there is nothing like coding to open the doors to so many career choices, whether it be in the gaming, entertainment, and virtual reality field, to more practical uses in controlling manufacturing processes, technology, utilities, and online services, to cutting-edge fields of space exploration, artificial intelligence, and quantum computing. An education in coding will be the basis for well-paid and exciting job opportunities for generations to come.